Why atomic bomb is the main concern in the world? The answer is uncontrolled. Nuclear decay happens inside, which goes for years as it is still affecting the Hiroshima. This is because of half-life, as radioactive elements not decay in one step. Half-life is a time in which radioactive elements decay into half of their atoms. A fire another half-life it decays to another half of its element and the process continuous for years in some elements. For example, if we have 100 atoms and they decay after half a life of 1 day, a fire one day they becomes half means 50 and a fire another day they become 25 and it continuous until they become 0. Number of half-lives can be calculated by using relation n equals no 1/2 power n. Here n is the remaining number of atoms, n is the original number, and the small number is the number of half-lives. Number half-lives how many times an element decay. Let's calculate it with an example where we have undecayed atoms equal to 50 and the original number of atoms we have to find after 1/2 of the lives. So by putting values we get the original number of atoms equal to 100. Half-time is the time taken by atoms to decay into half of its number. For example, 5 hours are taken by an element to decay into half of its number, then its half-life or half-time is 5 hours. If it is completely decayed after 5 half-lives, it means it takes 25-hour total time to decay completely. Total time can be calculated by using relation to equals to half-time into number of half-lives. How much chance an atom gets to decay depends upon its decay constant, which can be calculated by using relation lambda equals to 0.693 divided by half-time. As lambda is inversely related to half-time, which means that the decay process will be slow if half-life is long. And if half-life is short, then the decay rate will be high due to the high decay constant. When half-life is time-dependent, we use an exponential formula to calculate which is given as n equals to n, not into exponential minus lambda t. How many atoms decay in 1 second is given by activity, which is defined as the number of atoms decay in 1 second. The relation to find activity is A equals to n lambda. Here A stands for activity, n is number of undecayed atoms and lambda is decay constant. How activity is changed with time is found by relation A equals to A naught into exponential minus lambda t. Activity decreases exponentially because more atoms decay and start, and as time goes, the rate starts slowing down. This happens due to less number of atoms remain after every second.